Good evening, everyone, and welcome to Quantum Physics for Fools. Today we are going to be learning about tons of super cool quantum phenomena. The first is quantum superposition, which states that if the Copenhagen interpretation is correct, a quantum system can exist in a number of different states, and until the system is observed, it exists in a superposition of all the states. Once observed, it collapses into one of the definite states. This is really important for a lot of thought experiments, one of which we will discuss in our next video. Another phenomena is quantum entanglement, in which the quantum state of one particle cannot be described independently of the other, even if the two are not spatially connected. An experiment was done to try and prove this, where two subatomic particles are entangled in a state of superposition. If one is spinning in one direction, the other particle will always spin the other direction, even if there is no way for information to pass from one particle to the other. Another important idea is that the shorter the lifetime of a particle, the greater the uncertainty of its energy. This leads to quantum fluctuation, which is the idea that particles can come into existence without cause, as long as they exist for incredibly short periods of time. Quantum fluctuation contributes to the theory of quantum foam, which states that empty space is not actually empty. It is instead a sea of probability from which virtual particles manifest. Therefore, empty space actually has measurable energy. The last thing that we're going to talk about is quantum tunneling. Imagine you are playing catch with yourself, all by yourself, so sad, against a wall. You throw the ball, it bounces, you catch it. Throw, bounce, catch. Imagine you keep doing that, but suddenly it becomes throw, bounce, the ball falls through the floor. You may be thinking, what? An electron isn't a mole. It didn't tunnel through the ground. Sadly, this isn't Harry Potter, however much I may want it to be. We aren't at the brick wall at platform 9 3/4. This phenomena is possible through quantum tunneling. Because in the quantum world, particles have particle-wave duality and can behave like a wave, which does not end abruptly, and the probability function could extend over a barrier which classical atoms would not be able to move through. The electron can jump over this barrier. When an electron or photon moves over this barrier, it is called quantum tunneling. Though our prior example could not realistically occur, it can occur in the quantum world, and does, though not as often as one might think. That's it. Thanks!